Thank you very much for the invitation to speak today. I'd like to talk about polygenic scores in a Wisconsin longitudinal study. As you see there, I identify myself as a no PI of the Wisconsin longitudinal study. I do that explicitly because one of the most robust genetic associations that has been shown has been the relationship between having a Y chromosome and getting more credit for things than one often should. And in fact, the PI of the Wisconsin longitudinal study is Pamela Hurd, who is at Georgetown now, was at the University of Wisconsin. I am co-PI with her of the specific part of the Wisconsin longitudinal study about the genome data. We also want to acknowledge various funders. These are only some of them, but NIA and Russell Sage are prominent among them. A felicitous part of the Wisconsin funding is if you see up there Wisconsin Alumni Research Foundation, WARF. If you know a little bit about pharmacogenomics, one of the sites of interest in pharmacogenomics is the idea that genetic data can be used to better dose warfarin, which is a blood clotting medicine for treating people with blood clots, originally developed as a rat poison and originally developed at Wisconsin, and is in fact the big pot of money originally that animated the source of money that now funds things like our genetic data. The Wisconsin longitudinal study started in 1957 with what is unquestionably a very badly designed survey by any contemporary standards. Every high school student in the state of Wisconsin, or not quite every, but a very, very large proportion, received this in their senior year of high school as the initiative of one person in School of Education at Madison. And that survey really was important for a couple of different things that were on there that you can see here. The most important thing on that survey for everything that followed from it was the fact that the person designing the survey, for whatever flaws, had the foresight to ask the address and the name of the parents. That is to say that not only provided by surveying everyone a sample frame of Wisconsin high school graduates, but also a means by which they could be traced and contacted after graduation, which is how they were subsequently followed up. Now, not all of those Wisconsin graduates were followed up, but instead only a third of them. The Wisconsin longitudinal study, we sometimes refer to ourselves as the Happy Days cohort, because in the 1970s, one of the most popular television shows was the television show Happy Days. The Happy Days followed the adventures of a group of high school students who attended the fictitious Jefferson High in the state of Wisconsin, the city of Milwaukee. And in fact, those people from Happy Days graduated. We're part of the class of 1957. In other words, if you've ever seen the show, Ralph, Potsy, Richie all would have received this questionnaire about their plans in high school. Right? Now, if you know the show, the breakout star of that was the Fonz. The Fonz was actually a high school dropout and was a couple years older, even though he did receive his GED at the end of season 4. And so he would not have been in the study, but one of those three would have been sampled. The WLS is a 1/3 sample. And not only that, but over time, if you're familiar, say Richie had been sampled. Richie had 2 siblings, Joni and Chuck. Say that Joni subsequently would have been impaneled into the study in either 1975 or 1992. So we would have information on her as well, including perhaps today their genetic information. Because what built up from the WLS in what followed, right, is a real web of people reporting about themselves and reporting about other people in their lives. Over time, we have surveyed a graduate, a randomly selected sibling. We have early information about their parents in addition to them reporting about their parents. We have surveyed their spouses once, and we have them, the respondents, reporting on their children. Not only that, but the other thing that was remarkable foresight that you might have seen on that original survey is this thing that is up in the upper left-hand corner, because that HSR up there is high school rank. They had school administrators write in relative rank of the student in high school. And that HN there is the Henman-Nelson test of mental ability that was administered to individuals in Wisconsin as freshmen and juniors in high school. They looked that up from administrative records that are stored in the basement underneath the Wisconsin campus. That has allowed the Wisconsin longitudinal to study topics that you can't see anywhere else. That is to say, for example, one of the things we found is a relationship between that class rank variable, independent of the test score variable, right, and stronger than the test score variable, on health of individuals later in life. And we've even got some inklings of that with respect to mortality. In addition to that, now that we have genetic data, Jason Flesher, who is here, has been able to look at the relationship between, in other words, we have a pretty good population level cognitive decline data because we have this information effectively at a baseline when individuals were in high school and have followed them since. All right, so in the Wisconsin data, we have surveyed people at different points in time. The survey focus has shifted from originally being an education study to when the individuals were in midlife being effectively a social mobility and occupation study to as they got older becoming a health study, and now with the wave that will be coming up, it's a lot of it is to screen individuals and monitor their cognitive health and attempt to assess dementia. So following key points in the life period. But the other thing that is great is the linked survey data that we have and the opportunities that it provides. I mentioned how we have these cognitive test scores and high school grades, information from tax records from high school. That is information that you couldn't get for a population this age now if you were trying to go back. There's a lot of data that were available now that you couldn't have gotten then, but we are able to also, we've made earnings matches, we've gotten school resource information for both the elementary and high school. We're of course able to track the deaths, so even if we did never talk to the respondents again, we would be able to follow them as they pass away. We have Medicare claims data. We're now matching with the 1930, or we have matched with the 1930 census, so we have information on or 1940 census, so we have information on their modal birth year is 1939, and we even have information for most respondents from their high school yearbooks, right? So for example, we've had a study that's looked at the relationship between, did not find a relationship, but between later life cognitive health and whether you played football in high school, being able to base that on authoritative contemporaneous information on whether they played football. A retrospective report of whether you played football in high school would not be nearly as accurate, right? We also, I think, a key feature of all of the things that I've described so far, and this is becoming more prominent, right, is how we have sibling data and we have genetic information on siblings. I think this is especially important when thinking about cognitive scores because one of the things that you will see, just even as I was putting these slides together, things start coming up, people retweeting different things. But you see references here to this idea of polygenic scores for something like educational attainment, that the polygenic score is only, in a sense, a correlation, that the polygenic score is not something that can be thought of as predictive or causal. I do think that it is an important question exactly what that polygenic score is and how we could think of that as a causal variable. But certainly normal ways that people talk about correlation not being causation is not quite what the situation is with polygenic scores. For me, at least, the clearest information about that is what we can observe in siblings, like what we can observe in the Wisconsin longitudinal study. That is to say, and this is using EA2, but one of the first things we ran when we conducted EA2 was we showed, so this is looking at the relationship between the polygenic score and the average education between siblings, and then looking at the polygenic score and its relationship if one sibling has more education than the other. Right? You might think various kinds of ways that this would be correlation, but not causation. We'd see something between families, but you wouldn't see something within families. Right? So we ran this right away. I did not know how this was going to turn out when we ran it. I know other people had much more confidence than I did. But we showed this relationship between pairs, but then when we ran it within families, right, we see almost exactly the same association there. So when you talk about these things being correlation and not causation or not predictive, you do have to account for the fact that we are talking about something that we can show within families. So in other words, within a family, the sibling with the higher polygenic score for educational attainment is more likely to finish college and have higher educational attainment. The polygenic score provides interesting information for those of us interested in survey reporting. For example, in the Wisconsin longitudinal study, we have people reporting their ethnicity as Native American or American Indian. As people, at least in the United States, know, that reporting can be very iffy. A lot of people believe they have Native American heritage who perhaps do not. And one of the things that you'll see with that is that full siblings, of course, with genetic data, we know if you're a full sibling, regardless of whether you know if you're a full sibling. Sometimes siblings agree on their ethnic background, and sometimes they don't. What this graph shows is that the cases, the farther an observation is to the left, the more the person is overall principal components of the genetic data are similar to the average WLS respondent. WLS is overwhelmingly white. And the blue is different. And what you'll see is when the siblings agree about being Native American or American Indian, they're genetically much more different from the average, whereas people, when the siblings disagree, those people are not that different from the WLS sample as a whole. Right? To talk about some of the things that we have done recently or now with the WLS genetic data, again, some of these things involving data that are only a few data sets have. Sam and Ben and others have taken the lead on looking at the relationship between school data. So a nice thing about the WLS data is the average WLS respondent went to school with 30 or more other WLS respondents. Looking at the relationship between that polygenic score and educational attainment, what we find specifically is that while schools differ in the average probability of somebody finishing college, so in other words, you could go to a high school with two people who have the same polygenic score, but one of them goes to a high school where people are more likely to go to college from that high school. Those people are more likely to go to college. But we had thought that there might be evidence of different returns. That is to say that you might expect some schools to have a higher return or sort of a steeper relationship between the polygenic score and attending college. We did not observe any evidence of that in these data. Dan Belsky and others, we've been part of a joining of several data sets to look at social mobility and showing the relationship between the polygenic score and information about family background and social mobility. And then as the last thing that I'll show here, this is work that we are putting together now. But one of the things that Pam Hurd and I have been interested in, and Ben and others, has been the question of whether we can observe social constraint in polygenic data. And so in the Wisconsin data, we have information, you can look at it if you look at just strictly phenotypic information, that there was essentially that if you look at whether or not people attended college relatively soon after they finished high school, you'll notice that the polygenic score is more strongly associated with educational attainment for men than for women. Right? In other words, psychological traits we might think of as being more strongly associated with education for men than for women. We might think of this as being disproportionate social constraint for women. And we might think of that then as subsequently whether that reversed with the education that people retain later in life, which is something that women attain more of than men. But we see also that, in fact, that is the case. So this is the same graph. You'll see a reversal where now the relationship is stronger for women attaining for attaining education in college, right? So in other words, women you can think of as being the relationship. They have a weaker association between the polygenic score and educational attainment, but in effect they catch up with the education later in life. And also, interestingly, we observe this relationship that we observe here, the stronger relationship for men than women. This is the 1957 graduates in WLS. When we compare that to Ad Health, which is a much more recent cohort, we don't observe the same relationship. So that's all I have. Thank you very much.
Thank you for inviting me. That was great. Jeremy talked a lot about the research. Some of that was Ad Health, because I'm really going to talk more about just the polygenic scores that we have in Ad Health and how you get them. And I should apologize, because I'm just still getting over my post-holiday cold. All right. So I am actually the director of Ad Health. I've been so for about 15 years, but I am looking forward to the time when I can announce and step down that which will be in about a year and a half, 2020. So we'll have some new leadership there. Okay, so a little bit about Ad Health and why it's valuable for integrating genetic data. It's a nationally representative study of adolescents in grades 7 through 12 in 1994, and they've been followed for about 25 years now into adulthood. We've got information on 3 generations. We have 2 interviews on the parents at the very beginning, and just recently a follow-up of the parents. And we're also starting to collect data on the children, and we're beginning with their birth records. We don't have genetic data yet on either the parents or the children, but that is the plan. So one thing that was unique about the design of Ad Health is the multi-level and direct measurement of the social context in which adolescents live their lives, as well as the young adults following them through time. So we have information on friends, the peer network. Sorry, the red font is for, indicates that there are also genetic data available on the individuals within these contexts. So Ad Health was like WLS, we sampled clusters, we sampled schools, and that meant that the people in those clusters knew one another. So we try to exploit that to the best that we can. So we have information and direct measurement on the friends, peer networks, partners, family. We also have the sibling sample, and then schools, and then within the schools, of course, schoolmates and grade mates, neighbors, neighborhood, and the community. There's unprecedented racial and ethnic diversity in Ad Health because we oversampled certain ethnic groups. We oversampled Puerto Rican adolescents, Chinese adolescents, and Cuban, as well as a high SES African American sample. And then we do also have an embedded genetically informed sibling sample. We've got about 3,000 pairs of adolescents in the original design that have some genetic resemblance. So we have twins and full sibs, but we also have half sibs. And then adolescents who grew up in the same household but don't have any biological resemblance. This gives you the longitudinal perspective. We've got 5 waves of data. So wave 1 started 1994-95. This represents the prospective cohort that we follow over time. We started with almost 21,000 adolescents. Wave 2 was 1 year later. We did not follow up the seniors in this wave, so the sample size goes down a little bit. But then all subsequent waves, we went after all of the original adolescents who were in wave 1. And you can see that we're cutting across different time periods as well as obviously life stages. And we've had a pretty good response rate. Wave 4, which is the most recent completed wave, we're about 80% of the original cohort. And we're conducting wave 5 right now. We're in the midst of it. It's almost done, almost out of the field. The genomic data in Ad Health, it's just sort of interesting to note that in wave 2, 1996, we actually made our own kits. Actually, David Rowe was one of the PIs on Ad Health, is funded as a program project. And we collected DNA to check for zygosity. There were like 89 twins where the standard survey about determining MZ versus DZ twins just wasn't the case, which made for a wonderful experimental design that Dalton Conley took advantage of. And then in wave 3, 2001-02, we collected the molecular data on just the twins and the full sib, so it was about 2,600, again, using our own kits. By 2008, wave 5, the commercial kits were available. We used Origin, and we collected DNA on the full sample. We had a really good response rate. 96% gave us their saliva for DNA. And then the GWAS data actually comes from the archive sample, so those who consented to archive their data, because the GWAS data was not part of what we proposed and was funded on the program project. So that was just something additional that we did. So we're in wave 5 right now, and I thought I'd just let you know what's on the horizon here. We are collecting RNA data, so we'll have some transcriptome data, and we also have epigenetic data underway, based on the wave 5 archive. So the GWAS data, 80%, as I just mentioned, about 80% of the wave 4 sample consented to archive their saliva for further testing. That came to about 12,000 young adults. It took 2 grants over 7 years and 2 chips. We used 2 Illumina platforms, the Omni-1 Quad bead chip for most of the genotyping, and then for the remainder, we went to the Omni 2.5. After QC, the GWAS sample comes to almost 10,000, 9,974. I put here the QC report and the URL to get a hold of that. And, we have deposited our GWAS data finally into dbGaP. So if you want, you can make your own polygenic scores. Or we actually have 2 sets of constructed polygenic scores that are available to our users. We have 1 set where we constructed our own polygenic scores using the genotype data. So no clumping, no pruning. These are standardized polygenic scores within ancestry groups. We also released the first 10 ancestry-specific PCs. And this set are harmonized with HRS. I'd like to acknowledge David Broad, who's sitting right in the 3rd row. He constructed these polygenic scores, and this is the documentation for those. It's about 30, as well as the URL for that documentation. Excuse me. And here's what, these are the polygenic scores that have been released. They were released in July of 2018, and I'm happy to see there's already some papers that are in early preprint. So they fall within these categories. I won't go through them, but I think these slides will be made available. But we have a number under cardiovascular health, anthropometric traits, as well as the reproductive traits. Thanks to all of you who have produced these GWAS. And we also have on some health risk behavior, the tobacco use in particular, mental health and personality, and then cognitive health, and then of course education. And I put on there that we actually did release 2 polygenic scores prior to this larger release. And these are polygenic scores that are based on the sibling sample, a polygenic score for body mass index, and then also EA1. This is just a note here, and this is, again, as part of the documentation. This is the full list of all the polygenic scores, and noting that that not all of the polygenic scores are based on a GWAS that comes from European ancestry. And so, we have a number of cautions in the documentation. This is one of the tables that we present just to say that, individuals not of the same ancestry groups as a GWAS from which the summary statistics come from may be less predictive. And Jeremy touched on this as well. This is kind of interesting because we have such race and ethnic and ancestral diversity. We release 4 ancestry-specific polygenic scores for European, African, East Asian, and Hispanic. We use PC analysis for determining ancestry, and you can see that the self-identified race ethnicity, for the most part, falls within the ancestry, but of course it's not surprising that some who self-identify a different race or ethnic group fall into a different ancestral group. Okay. So these are the SS-GAC polygenic scores that have very kindly and expertly transferred to us from SS-GAC. And so there's two sets. There's the standard GWAS, and of course these are specific to their methodology. So this is using the LD-PRED, and also there's somewhat different determination of ancestry and more refined, as well as the MTAG polygenic scores. And I've listed here the documentation, which we've just been nailing down. And we expect these will be available, or these will be released, so there'll be an announcement that goes out next week. And this is great because this is all, I just put up here some illustrative publications that have been using the polygenic scores. Jeremy talked about a couple of these. And the first one, for example, does, use the SSGAC-EA3. The bottom two are actually based on those earlier sibling samples and polygenic scores. Okay, how do you get the data? Here's our study website. On the website, we've got discovery tools. We're also setting up an omics page that will help people, give them tools for getting access to the data and using the GWAS data. For example, we've got a pipeline script set up there. But the way you get there is through this CPC, which stands for Carolina Population Center Data Portal. That's how you apply for the data. You want to get restricted data, and that requires you to set up a couple security protocols for keeping the data secure. This is what the data portal looks like. You would identify Add Health and then put that in your cart. You'd want to go into the restricted data use. This is what you say you're interested in the polygenic scores. This is the page that you would see. The very bottom are the polygenic scores that Add Health has produced, and the very top, for example, are the sibling polygenic scores. And then this would you come up to the description of them, and then you would add that to the cart, and that is what the page will look like for the SSGAC scores, which will be available hopefully next week. And just to put this up, we're in dbGaP. This is the study accession number. This is what it looks like on dbGaP, for those of you who'd like to go directly there. I should say that on dbGaP, are the genotype data as well as the imputed data, and pretty much nothing else. I think we've got height. And so, after you get approval through dbGaP, you then come back to Add Health. The linking variable that is available through dbGaP does not really, link to anything, so you come back to Add Health. And then we give you the link to all the phenotype data. Just make sure that your restricted data contract is all set up. And that's it. So these are our co-funders that, we wouldn't be here and wouldn't be here for so long without them. Thanks very much.
Good morning, everybody. My name is Jessica Faul, and I am one of the co-PIs of the Health and Retirement Study. But I'd like to acknowledge that there are 17 of us, so it's very much a team effort. As well, we are a cooperative agreement with the National Institute on Aging, so without their support, we would not be here. And I don't want to spend a lot of time on what the HRS is, because it's big and complex, and I really wanted to focus on the polygenic score portion of what we have to offer. But just to let you know, it is a longitudinal panel study surveying a representative sample of people in the United States over age 50, as well as their husbands, wives, or partners. It's been ongoing since 1992, and we interview people every other wave. And like Add Health, we also have, or every other year, and like Add Health, we also have oversamples of African Americans and Hispanics. So we have fairly large minority subsamples, which allow for a lot of different types of work. We cover a lot of different domains in the survey that we do, and I encourage you to go to the website and find out if sort of your favorite sets of questions are in there. And as well, we also have a lot of linkages to administrative data, so Medicare claims, Social Security data, we used to have validation of death from the National Death Index, but we still have information on mortality. So you can get a lot of information there, so go ahead to our website. But today I wanted to talk about genetic data and what we have to offer. We've been collecting salivary DNA since 2006 using mostly the Origin kit, the same kit that AdHealth uses. We've genotyped those data using the Illumina 2.5M Omni platform, sometimes including the exome data. Version 1 and 2 of these data, so the samples that we collected in 2006 through 2010 are already posted on dbGaP and available to download. And like with AdHealth, it has an identifier that's not really meaningful in and of itself, but you can come to HRS to get the linkage to the survey data. We have really about 19,000 samples that have been genotyped already, so data through 2012. Those data have yet to be released. We're trying to find a good repository to do that for us quickly, and I'll talk a little bit more about that later. And this includes both the genotyped and the imputation. So over time, we've used different imputation panels. The most recent is the imputation panel from the Haplotype Reference Consortium. I wanted to talk a little bit today about sort of why we got into this business of polygenic scores, because I think we were the first study to kind of go out there and decide to release these publicly. I think, as all of you know, they're very attractive in thinking about doing gene-environment interactions, because it allows us to take all the information we know from the genetic data and combine them into one measure of genetic risk. It also allows us to have sort of a hypothesis-free measure. You don't really need to understand or know the biological mechanism to combine these data together. But really, our real motivation was that we knew that there was a lot of access issues in using the full genotype data, and we wanted to create something that was more accessible to people who didn't necessarily want to go back to school and get a whole degree in genetic epidemiology. So we created these polygenic scores to be distributed as a public data release product. We also recognized pretty fast that there were a lot of different ways to create these scores, and if we wanted to facilitate replication, we thought it would be a good thing to present one set of scores to the user public, so you at least would know that you used the same score as somebody else, and that wasn't a methodological issue that led to you having different results. So as I mentioned, there's a lot of different construction methods that you can use, and you can get slightly different or significantly different R-squareds using these different methods. But we needed to find something that would work even if we didn't have the measured phenotype to test the predictive ability against. So some work led by my colleague Erin Ware tested 217 different methods of creating the polygenic score. For phenotypes we did measure, so we could see how well they did. And this work is posted on bioRxiv. We found out very quickly that using the top hits to calculate the polygenic score was not the best method. In this table, it's the score to the bottom left there. And here you're looking at different decision points, clumping and pruning, what p-value we use as the cutoff. And what we found is that, in general, the best method across most of the phenotypes we tested was if we include data from the entire genome with no clumping and no pruning, so including everything with a p-value, up to a p-value of 1. A lot of people ask us, why don't you do LD-pred? And so what you can see on this very oddly colored table up there is that the method we use is the dark bar, the dark blue bar. LD-pred is the one next to it that's sort of yellowish looking. The best method that we calculate across all the methods for these different traits, so here we have height, BMI, educational attainment, and depressive symptoms, is the pink one. So as you can see, the one we release isn't always the best one, but most of the time, it's not significantly different from the best one, and it's not usually significantly different from the LD-pred version. The one case that is different here is height, which is the one on the far left, and we find this a lot, that things that are very genetically determined, often this no clump, no prune isn't necessarily the best one, but those are pretty rare. So the LD-pred version is not usually significant from the one that we do, and the reason why we picked the one we do is that we often don't have access to the summary statistics that would allow us to calculate the LD-pred version. And so that was just sort of a limitation in why we chose to go the way we did. This is a depiction of Erin's pipeline when she creates the polygenic score. The top is what you have to do to your own data to get it ready, and the bottom is what we think about when we get the GWAS data ready to calculate the polygenic score. So we have to obtain the summary statistics from the GWAS consortia. We usually have to ask them to rerun it without the HRS included if we were part of the discovery or replication sample. And for consortia that have used 23andMe, we have to ask them to run it without that as well. People also ask us, how do you select which polygenic scores you're going to calculate? And most of the time, we're really looking for large replicated GWAS that have phenotypes of interest. So for us, things related to sort of educational outcomes, social outcomes, health outcomes related to aging. But we're looking for things that are fairly sizable so that we can create better scores. All of the polygenic scores are released publicly on our website. So if you go to hrsonline.isr@umich.edu, you will find them. Our first release of scores was in May of 2017, and that included data from the 2006 and through the 2010 samples, so for about 15,000 samples. We released a second version with 27 scores in April, and again a third version in October. So we're now up to 38 scores. So about every 6 to 9 months or so, we sort of see where things are. If cohorts, or if consortia have updated their results, we'll update our scores. If new ones have been published, we'll add those to the list. If your favorite one, these are not complete lists, the complete list is on the website. If your favorite things are not in here, let us know and we will add them to the next version to be released. And as Kathy already alluded to, other studies are using the same method. So we are really trying to work hard to harmonize the methods that we're using across the different cohorts that have genetic data, so AdHealth, WLS. I'd like to mention that ELSA, the English Longitudinal Survey of Aging, one of the HRS sister studies, have also created their polygenic scores and we'll be releasing them shortly. And then the Fragile Families and Child Wellbeing Study is also doing polygenic score creation using the same method. Another thing we were really interested in was finding out whether it mattered what genotyping chip you used when you created the scores, because the scores that we create only use the genotype data and not the imputed data for the most part. And Erin has done some recent work to show that the scores are comparable across the different genotyping arrays. So it doesn't really matter so much whether you have the 1 million chip or the 2.5 million chip. Pretty much the scores are come out to be pretty comparable. I want to point out that for us, at least, the polygenic scores are released for both the European ancestry and African ancestry groups separately. And we include the ancestry-specific principal components, but they are masked. And as Kathy already alluded to, it's important to note that the majority of the GWAS that are used to inform the SNP weights come from GWAS and European ancestry groups. And so they don't have the same predictive capacity across other ancestries. So we recommend that these polygenic scores not be used to investigate racial health disparities. And as things change, we will change as well. So as more GWAS are published from larger samples of other ancestry groups, we will include those in the polygenic scores that we release. I also want to point out that the calculation of these scores is completely dependent on the availability of summary statistics from the GWAS that are published. And just as a warning, consortia are allowing cohorts now to opt out of the release of the result sharing. So when cohorts are participating in a GWAS, they can select whether their data will be included in summary statistics that are released. And so increasingly, we may find ourselves in the situation where the scores that we're able to calculate don't represent the full set of results in the GWAS. Thanks. So it might be kind of a patchwork type situation. So read the documentation carefully so that you understand where the scores come from and what's included. It's my own personal opinion that the summary statistics from the meta-analyses, really, we need to push hard to make them more widely available to the research community because it's one of the really beneficial things that come out of these GWAS projects. And if you are a person in charge of a cohort study, think very carefully about whether you want your cohort to participate in a GWAS if you don't feel comfortable with the summary statistics being released. Again, creating this patchwork situation is not ideal for us going forward. And the NIH has a new genomic data sharing policy, which we hope will lead to sort of better data sharing in the future. But there are some groups that are in a bind because of the inclusion of 23andMe, and we recognize that and are trying to facilitate the release of scores, including those data. So data from the SSGAC falls into that bucket. And so with their participation, we release scores that they have been able to create for us, including data from 23andMe. So we include on our website the ability to download data and polygenic scores from the SSGAC using sort of, as Kathy said, both the MTAG and PGS scores. And so we have these in a researcher contribution section of the website. So you can go there and download the same scores that you can see in AdHealth on educational attainment, depression, neuroticism, and subjective well-being. Right now, scores are currently available for the 2006 and 2008 samples, but there are many more scores in progress that will include the full set of available data from 2006 to 2012. So we're excited to get those soon. Just our plans for years 29 through 34 of the HRS, we are continuing to update and distribute the polygenic scores as a public data file. We still continue to collect DNA and saliva, from saliva and venous blood from our respondents, and we have about an 85% response rate for the contribution of DNA from our participants. We are currently genotyping samples from 2014 to 2016, which include one of our new cohorts. This will be about 3,000 additional samples, so that's in progress. And we're constantly struggling with how to best distribute these data, and we will potentially move from dbGaP to distribution from NIAGADS for our genotype data. So if that happens, we will make sure you all know, so stay tuned. I just want to quickly acknowledge that this would not be possible without the generous participation of the HRS respondents and their families, which include about 38,000 people at this point. And again, support from the National Institute on Aging and many of the HRS investigators and collaborators that have been instrumental to the Polygenic Score project. That's it.
You know, this discussion is both questions to the speakers, but also general discussion on topics related to the session. And it's great to have kind of ongoing interchange, and we'll try to, we don't want to cut short any, if there's an important topic that comes up, we should just keep talking about that topic until, until it's exhausted, and then move to the next one.
My question is to Jessica. Okay. So when you said you didn't do LDPRED because you didn't have access to the summary statistics, so which summary statistics and why?
Oh, do you want to pass the microphone to Jessica? Thanks.
So in some cases, we probably could, but we were looking for a method that would allow us to use the same method across all the GWAS that we wanted, from which we wanted to create a score, and we can't get some of those summary statistics historically from some of the sort of older GWAS. Again, we started this several years ago, so some of this information wasn't as accessible then as it is now.
That applies to all scores, right? Not LDPRED specifically. So LDPRED doesn't require you to have any additional data other than what you have for other scores.
Well,
you mean you don't have access to genotype data?
no, I'm not talking about, we need the summary statistics from the GWAS, and the LDPRED requires us to have certain things like the standard deviation, and allele frequencies that we can't get from the consortia that ran the GWAS, every GWAS. So it just requires a different set of input information, not the genotype data. So I'm not saying the data that we are building the scores for are different. I'm saying the summary statistics information is different using the different methods, and that's why we chose to go with the one that needs the least amount of summary statistic information.
John King.
Yeah, I'll just shout. John King from National Institute on Aging, or NIH. Recently, we did release, as Jessica noted, OED 19023, which is the update to how genomic summary results should be shared. It's really important because it should lead to actually a lot more of summary statistics being shared. But there's some unfortunate exceptions and carve-outs for things that could be considered sensitive because they affect certain sorts of phenotypes. Which is a problem, because most of them are not that sensitive. In the past, educational attainment has been withheld from studies as being, for instance, sensitive. So I think that what would be useful, I can't do it, and I can't suggest anyone specifically do it, but if there were a website that would actually sort of record which GWAS summary statistics are publicly available and which ones are not and why not, This could be a useful public resource for people that can sort of see what's not, and perhaps communicate further with those investigators who are withholding statistics. It's my personal opinion. No endorsement from the government.
Okay, so Michelle. Yeah.
Thanks. So for all three speakers, out of curiosity, do any of your studies have ever you thought about returning individual results, whether polygenic scores or even non-genetic data, just as a gesture to your participants? Just curious. Certainly some platforms are starting to return those things.
Yeah, this has, of course, been an area of a lot of evolving understanding among longitudinal surveys, I think, especially. In the case of WLS, as I mentioned, we are going to be going back to respondents with the goal of trying to get information that would screen to whether they have cognitive impairment or straight up dementia. And that, of course, in our case, we will definitely, we're figuring out exactly how to do it, but we'll definitely be having a protocol for what to do if we have reason to think that we have information about their cognitive decline that they do not themselves yet have. Yeah, so it's a discussion that, in fact, we were just talking about earlier this week.
In the health and retirement study, we routinely give information back to our respondents a lot related to the biological data we collect. The one exception so far has been the genetic data, and I think it's in part just because we don't feel we're yet at a point where we can communicate individual risk very well to a participant. In addition, they haven't consented to get that information back. But it is something that we're constantly reevaluating, and as things change and we know more, our policy on that probably will change, but we will have to ask them specifically whether that is information they want to have returned to them.
Yeah, in HRS, I'm sorry. Thanks, I told you I had a cold. In AdHealth, we do not return genetic data. Primarily, our decision-making has always rested on whether or not it's a diagnosis. So, for example, in wave 3, we collected urine and saliva. We tested for curable STIs and HIV, and we did return those results anonymously. In wave 4, we collected blood spots and had a number of assays, and we did not return those results because they were not a diagnosis based on blood spots, that we could actually do more harm than good. If any of our respondents are way out of range, we indicate that they should see a doctor and give them resources as to where they would go. So that, the diagnosis aspect, given that our genotyping has mostly been done on saliva, we now, have fetus blood. As Jessica said, things may change, but, the saliva-based genotyping, I don't think would be a good basis on which to inform respondents about something that is, that is not diagnosis within the clinic. But to the extent that now we're doing biomarkers on blood and we are returning results, for example, on hemoglobin A1C and other sort of, clinical results.
Peter Vischer?
The utility of polygenic scores would increases the higher the correlation between the predictor and outcome, just in any application. And that prediction accuracy tends to increase the larger your data set you have to estimate the SNP effects. So if you it's great to release polygenic scores from these cohorts, as we just heard. I just wanted to ask whether you have plans to regularly update those. For example, the genetic predictors we work with for height now predict 30% of the variance and not 10%.
Yes, absolutely. We will update.
So yeah, if, as Jessica said, if you have a phenotype of interest that we do not have a polygenic score for within Ad Health, and I think I can speak for HRS as well since they already said it, send us an email. Let us know what GWAS you would like added. We're constantly looking to update these. As HRS has done, they have release 1, 2, and 3 now. Ad Health only has 1 release of these polygenic scores, but in the coming months, we will be updating with a release 2 because of the sample size issues, right? As we get more power, these will become more predictive. Therefore, we will be releasing better polygenic scores as the summary statistics become available, which goes back to the other points. Please release summary statistics. The more patchwork this becomes, the harder it's going to become for studies like Ad Health, HRS, WLS, and all these others that are coming on board to release high-quality, replicable, and harmonized polygenic scores between studies without requiring a second PhD, unlike some in the room that have done that, right, in order to do the research we want to do.
In the back? In the back, I'll come to you next.
Hi, thank you. David Llewellyn from Exeter. It seems obvious that a lot of effort is being wasted, and people are, within individual cohorts are doing their own thing largely, whether they're, even when cohorts themselves are deriving these polygenic risk scores, they're not necessarily comparable between studies. So I think it's really useful when people like Jessica, she's talking about doing things in the HRS, but also doing things in ELSA, for example. So I think that would be very much to be encouraged, because then we can pull data, we can do bigger analysis, the kind of things that we're going to lead on to talk about, through this conference. A lot of it requires bigger sample sizes than even the biggest individual cohorts. So I think the more we can harmonize, make things efficient, and facilitate data pooling, the better, really.
Absolutely. Nick Papageorge? You want to take the microphone? So.
I'm loud, though.
Yeah.
This is awkward. I don't like these. All right. So I've never worked with the Ad Health. So I was trying to understand. There was something about like a restricted access data. So if I went like next week, if a student went next week to like just download the EA score, for example, like how hard is that going to be? Or like how many things do I have to sign, or what kind of IRB do I need?
Yeah, so our data are not downloadable. From the start of Ad Health, we've always had extremely high risks for deductive disclosure because, we sampled schools, we interviewed all students in those schools, and everybody in that school, all the parents, all the teachers, knew of somebody in that school. So it's really, really easy to identify people. So what we have is a public release sample, which is downloadable, is a 50% sample, and it does have biological data, but we don't disseminate our genetic data. So you have to go to the restricted use data contract. So it's a contract. You apply online. How long does it take? What you have to do is come up with a security plan for how you will use our data, just to make sure that you do not publish any result that's based on less than 5 individuals, that kind of thing. So it's like the census, but not quite that restrictive. And the security plan has to be put through your IRB. So that gives you some idea of what you have to go through, but it's all, the application process is automated, it's all online, put it in, tells you what to do, but then you do have to go, perhaps work with your IT person. You could set up Ad Health on a standalone computer, you could use an external hard drive, any kind of thing, just as long as it's not networked. So it's really easy to hack in. Get that through your IRB, and then it's just a checklist. You say, it's a big long list of what data do you want? You want wave 1, wave 2, wave 3, the parent data, the biological data, the genetic data, so on. And then it gets delivered to you on a CD. You put that in your context. So, it could take as long as 1 month to 6 months, depending on, on what you do and, how your university setting. It's a legal contract that is set up between the University of North Carolina and your institution.
Can I add something? no distinction between the underlying genetic data and polygenic scores or secondary products.
There's no distinction. So the only way that you can get the genotype, the full genotype data is through dbGaP. But then you come back to us and we give you the full phenotype data.
The security procedures you just described also apply to polygenic scores.
Yeah, sorry, I think I said that wrong. So the polygenic scores you get directly from AdHealth. You don't have to go through dbGaP.
Yeah, but you still have to go through all the security procedures.
Yes, both. Yeah.
But
Exactly.
you don't have to download the data from dbGaP for the
Right.
polygenic scores.
Okay, I think I got it. Yep.
John King?
Just very briefly on the questions about harmonization and such, it's come to our attention that a lot of the studies that have been doing this great work to get GWASs done and things like this, we're really not budgeting in advance for the need to constantly recalculate and update the scores to keep them state of the art. So those who are running such cohort studies who are interested in seeing more, if you just quietly tell me what the cost structure of this looks like, it's possible that something could be done to because really, to be really honest, in the last 2 to 5 years, there's just been such a humongous increase in the number of available and well-powered GWASs that nobody writing the grant 5 years ago could possibly have understood the amount of time and effort it would take to keep them up. And yet, these are clearly some of the most valuable general data we have. So this is definitely a situation where it's not just for polygenic scores, it will also be for MR and be for a whole bunch of other things. We really need these things to live.
Hi, Melinda Mills from Oxford. I was trying to time the moment when I could do a shameless advertisement for our new polygenic score, and this might be the moment. It seems well timed. So I led the original one on reproduction, reproductive behavior, so age at first birth and number of children ever born. So we have one coming out with a substantially larger sample size on age at first birth, number of children ever born, childlessness, and age at first sex. So although it hasn't been linked in the literature, we have a hunch that sex and fertility might be related. We connected them in this study. And we also, for those interested in studying selection and evolutionary processes, we've linked it with ancient genome data as well. So there's lots of really super cool stuff coming out. I'm assuming some of the reviewers are in the room, so be kind. So yeah, thank you. And the summary statistics thing, it's a real frustration. I think that funders and editors, I mean, I've ranted on this before, should actually enforce it because it's a form of power that people don't release their summary statistics in some consortiums, and it's really irritating.
Quick reaction, David? Yeah.
I just want to make a comment on the wasted effort and the harmonization. Aaron Ware's done a lot of work to harmonize these, and I've done work at AdHealth, and we've both done work to try and bring in other cohorts to harmonize the polygenic score creation on these. And so definitions of ancestry are identical between AdHealth and HRS for those that overlap, right? And so these types of methodological harmonizations are important. And just to go back to that wasted effort part, we've been doing our best to try and make sure that these are available and as identical as possible.
All right, so we're going to take a break now for 15 minutes.